force due to a current carrying conductor. And what does actually this means? When a current carrying conductor is placed inside a magnetic field, it start experiencing a force. Okay, and this is the important relation between magnet and the means we can say the force and the magnet. Okay, what is it actually? When a current carrying conductor, a current carrying conductor is placed inside inside a magnetic field, inside a magnetic field. Okay, then it start experiencing force. Okay, then it start experiencing a force, and that force. Okay, and why it is start experiencing a force? We should discuss this one. Okay, and this that force is given by I B L sine theta. Okay, where F is the force, F represent the force, B represent the magnetic field, power of magnetic field, magnetic, okay, magnetic field, okay, and L stand for length of the conductor, length of conductor. And you know that if these all three things are directly proportional, if more I, more will be the force. If more magnetic field, then more will be the force. Length of the conductor is more, then there will be more force. And sine theta here, theta is the angle between force, sorry, angle between current, current and magnetic field. Okay. IBL sine theta means the current and magnetic field. The current, direction of current, and magnetic field direction. Okay.
Yes, sir.
Magnetic field direction. And you know very well that theta, if theta means we can say that sine theta, sine 0 is equals to 0 and sine 90 is 1. Sine 90 is 1. Okay. Sine 0 is 0. Okay. And sine 90 is 1. And the maximum power of sine lies between positive value of sine is value of sine is, tell me, positive value of sine is
0 to
like from,
90.
yes, 0 to 1. Okay, the maximum value of sine is from 0 to 1. Okay, positive value. Or we can like say that if it is, means if sine goes from up to 180, then it will going to have -1 value. Okay, so this is the values that we are talking about. Okay, the graph of sine is like this. The graph of sine theta is like this. Sine 0 is 0. Then we have 90. Here it is 1. This is, okay, this is -1. So at 90, it is going to have the maximum power. Then at 180, this is 180 degree, and it is again going to have 0. Okay, then at at 270 degree, and it is going to have -1. And then at 360 degree, again, it is going to have 0 value. So sine's value lies between -1, then 0, and then +1. Okay, and the positive values is from 0 to +1. Okay, and this light at sine 0 degree. Okay, sine 0 degree at 0, and sine 90 degree is 1. Okay, now I'm talking about the force. Force is equals to IBL sine theta. Okay, so if the current and the magnetic fields is going to be have, means they are placed at 90 degree to each other. Okay, 90 degree to each other. Like if this is the current direction, I, and this is the magnetic field direction, and the angle between them is 90 degree. So the force will be maximum. Okay. Okay. Why? Because here sine theta value will be 1. Sine theta value will be 90 degree. And when you put the value F is equals to IBL sine 0, sorry, sine 90, then it will be IBL into 1. This will be the maximum value. Okay. As you keep the angle decreasing, like if it is I is like this one and the magnetic field is like this one, the angle is being less than 90 degree. So the value of this one will be less than 1, and the overall value will be less. Okay. Got it? So means more the theta up to 90, more will be the value. Okay. And less the theta between 0 to 90, less will be the value. Okay.
Yes, sir.
So the maximum value is 1. So if you have let's suppose this is 60 degree. So sine 60 is root 3 by 2. And if it is, let's suppose it is 30 degree, this will be half. Okay. Got it? And the angle
Yes,
between
sir.
them is, so this will be the force will be become half because sine 30 is half. Okay. Sine 30 is half. The same, if you keep on decreasing the value, you will find that the sine theta, and when you have current and magnetic field, okay, if you have current and magnetic field in the same direction or in the opposite direction, because at 180 means 180 is also going to have 0. So if it is, if the current and the magnetic field are in the same direction, or if they are in the opposite direction, exactly opposite, magnetic field and I, then the sine theta will be 180 degree, or sine theta will be either 180 degree in this case, and here sine theta, sine will be 0 degree in this case, sine theta will be 0 degree, and the both is going to have 0 value. At 180 it is going to have 0. Okay. And at 0 it is going to have 0 value. Okay. Got it? So either the
Yes, sir.
magnetic field and the current are in opposite direction, then they are going to have value. Then no force will be acting on the conductor if the current and the magnetic field are in that direction, in the same direction, okay, or in the opposite direction. Now the questions comes here that why do question comes here that why do current carrying carrying conductor is experiencing this force. Why do, when it is placed in a, this force, when it is placed in a, when it is placed inside the magnetic field the reason behind this is that when there is a current carrying conductor, okay, so moving charged particles behave like a magnet. Okay. You have seen in the Oersted experiment that when Oersted was performing an experiment, and the current was flowing in a conductor, that I current is flowing, and near this is a magnetic compass needle was placed. Okay. Then when the current is flowing, then this current carrying conductor was behaving like a magnet, and this due to that this compass needle was deflected. Okay. Because when a current carrying conductor or when a charged particle move, then it produce magnetic field, and you know that when there is a magnetic field, like it is producing some magnetic field, or we can say that magnetic field is produced by magnetic field magnetic field is produced by magnets. Okay. And you know that one magnet exert a force on another magnet. Like if we are having, this is the north pole, this is the south pole, and if I'm having another, this is the south pole, this is the north pole, so it will repel each other. Okay. And if we having north pole and south pole, and here we have north pole and south pole, they will attract each other. Okay. Attract each other. So when a current carrying conductor is placed in a magnetic field, so this current carrying conductor will have its own magnetic field, and when we are just providing another external magnetic field in to this one, then a force will be exerted. Okay, a force will be exerted. You understood?
Yes, sir.
So this is the reason that why do when a current carrying conductor is placed in the inside a magnetic field, because a current carrying conductor is also a magnet, and when we provide another magnetic field, okay, towards it, then we will simply say it that they will experience a force. Okay. And this force uh the direction of this force was given by Fleming left hand rule. Okay. The direction of this force was given by Fleming left hand rule. And what is Fleming left hand rule? Tell me, what is Fleming left hand rule?
When you stretch out your thumb, forefinger, and your middle finger, that they're mutually perpendicular to each other, then the thumb is the force, the forefinger is the magnetic field, and the middle finger is the current.
Okay. Okay. So we can say here that that hold your yeah, you are right. That first of all, we are not going to, because we are just actually in Fleming left hand rule. We know that we are just actually calculating the direction of force. Okay, when a current carrying conductor is placed inside a magnetic field, so the direction of force should be represented at the last. Okay, means we cannot say that if we are having hold your forefinger, middle finger, and thumb mutually perpendicular to each other, such that the thumb point the direction of force. No, we are just actually calculating the force. So it should be like this: hold your forefinger, middle finger, and thumb mutually perpendicular to each other, such that if the forefinger point the direction of magnetic field, your middle finger point the direction of current, then your thumb will point the direction of force. Okay, there, because we are just calculating the force in this one. So last point will be should be regarding to the means thumb. We should write that then the thumb will point the direction of force. Okay, you understood?
Yes, sir.
So let's write down this law that Fleming left hand rule. Fleming left hand rule. What does it says? It says hold hold your forefinger, four forefinger, comma middle finger and thumb of your left hand. Okay, thumb of your left hand. The students forgot to write this one of your left hand. Okay, so you have to write this one of your left hand mutually perpendicular to each other. Mutually perpendicular to each other. Okay, mutually perpendicular to each other. Such that such that 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 your thumb, sorry, your forefinger point the direction of, point the direction of current, sorry, magnetic field, magnetic field, your middle finger point the direction of current, then your thumb will point the direction of force. Okay, so this is the law that we need to understood this one. Okay, this is the law that we need to understood this one. So this is very important. Okay, Fleming left hand rule. Got it?
Yes, sir.
Now, what we are just going to know here is that how can we find out the values of this one? Okay, this is the 3D one that we're just going to have, because I cannot make my fingers here to present you. So I'm just drawing this one. Okay. And if I'm having, let's suppose this is the positive. Okay, this one is positive y-axis and this one is negative y-axis. We can take y-axis only. Okay, we are just saying positive negative axis. Okay, we are just having this axis like this, like this. Okay, and like this. So if it is x-axis, this is y-axis, and this is the z-axis. Okay, got it?
Yes, sir.
Now, this is very simple that how can you represent this one? That this can be represented by a simple method. Okay, by using your Fleming left hand rule and holding your forefinger. For example, if this is the thumb. Okay, just we are just having I'm just holding my right hand, sorry, left hand, four fingers, middle finger and thumb mutually perpendicular to each other, such that this is my forefinger and it is representing the magnetic field. Okay, and uh, this is my finger that is representing the current. Okay, current. This is my forefinger that is representing the current I. Then which axis, or we can say that the positive uh, y x-axis or negative x-axis will represent the force.
Positive.
Positive x-axis will represent the force. This will represent the force. Okay, got it?
Yes,
Now,
sir.
if suppose next case, I'm just having different colors. If I'm saying that this is the force and this one is the magnetic field, okay, then in which direction is the magnetic field is going to lie? Sorry, current is going to lie.
Sir, the positive z-axis.
Positive z-axis. No, it should be inside the z-axis. Huh? Check it. Inside the z-axis. This is going to be I.
Yes, sir.
Okay, got it. You made it, or should I help you? Should I help you?
Yes, sir. Please.
Okay, just I'm going to give you a trick here. Okay, and you can remember it by making these diagrams. Okay, so this is IMD. You have to write these words. Okay, IMD, and this is MIU. Okay, and what is IMD? What is IMU? You can learn it by your any. You can make any tricks to learn this as IMD and MIU, and this is generally for the force. Okay, and you can consider this one. D is the direction of force, which is means I stand for current, M stand for magnetic field, and D stand for the direction that is either downwards, okay, or away from you, or away from you. Okay, this is the direction of force. Okay, and this is either it can be this is magnetic field, this is I. Okay, this is magnetic field direction. This is current direction, and this is the direction of force. And U stand for towards you. U stand for upwards, or towards you. Okay, okay. Now there is a cycle that there is a rule for this. And what is the rule? That either you have to use this rule IMD or you have to use MIU. Okay. The reason is that what the trick, the simple trick is for this one is that whatever the plane you are choosing, you have to choose the shortest path. Like this is the I and this is the M direction. Okay, M direction. So you have to choose means you have to go to means you have to touch make this one. Okay, what I'm saying here that you have to touch this one or you have to join this line I and M both. But one way is that you can join it like this way. Another one is you can join it like this way. And the third way is you can join this like this way. Okay. First of all, the rule is you have to choose the shortest path. Shortest path to join these two. Okay. Shortest path. And the second rule is simple that you have to, first of all, either you have to join the shortest path. Oh, so use the shortest path. And the second one is you have to use clockwise. Clockwise always. Always. Okay. Clockwise means this way. Okay. Got it? Got it?
Yes, sir.
Okay. Now, if I'm saying that, let's suppose if I'm making this box again for you, or I'm just making the practicing this one. Okay. This one, the same box we are just having. Okay. Just this is very simple for you. If you learn these two tricks, then it will be very means helpful for you. Okay, you can easily do, and you will never get stuck to here. Okay. For example, if I'm having I here, okay, and M here, okay, this is 90 degree to each other. We have used z-axis and okay, and x-axis. The only axis the force is going to be either this one or this one. Hmm? Upward or downward. Understood?
Upward. Yes.
Now what you are saying here that there is you have to join these two. You have to use the shortest path. You cannot go like this or you cannot go like this. You have to use clockwise direction. Okay. So only the possible thing is that you have to use I M D. I M. You have to use I M and D means it will be downward. The force direction will be downward. Okay. Let's suppose instead of I M D, let's suppose if I'm having this trick, this that this is M magnetic field upward. Okay, got it? Got it?
Yes.
And this is the magnetic field is upward and this one is current. Okay, now this is the 90 degree here. Got it? Now you have used z-axis and y-axis. The only axis that it can be from this direction or it can be like this direction. The force can be either in this direction or in this direction. Okay, now this is M, this is I. You have to choose the shortest path to join M and I. You have to use this word, this path now. M I. Got it?
Yes.
Then M I U. M I U. Okay. M I U. Okay. Now tell me if you are joining this M I. Okay. M I. So this is the clockwise path now.
Yes, sir, clockwise.
Clockwise. So do you think that you are standing here at A position or here if you are seeing this at B position? Where are you looking at?
Sir, from B.
From B, na? So this is M M I U. U means towards you. So it will be towards Z axis, X axis. Okay, you can do this one by your hands also. If you try to this one, then choose that you have place your forefinger upward. Okay, upward in the upward direction, and this middle finger that is representing the current that should be into the screen. Then your force will represent the positive x axis. Okay.
Yes, sir. Okay.
Okay. Next. Let's suppose if I'm having let force is in this direction. Force is in this direction. Okay. And current is in this direction. Current is in this direction. Okay. Now you know that this is the 90 degree angle. Okay. Okay. Now, where you think that you are standing? You have to choose according to your wish. If you are standing here, then this force is towards you. And if you are standing here, then this force will be away from you. Are you getting my point? You
Sir,
have
can
to
you
choose.
explain that again?
Yeah.
Okay.
For example, if this I'm saying that force is in this direction, okay? Force is this one and I is this one and magnetic field is being asked now. Magnetic field is being asked. Okay. Now, imagine that where you are standing yourself. Are you standing? I means it's your choice. Where do you want to stand yourself? Okay. If you want to stand yourself here, then this force will be towards you. And this will be, okay, this force will be coming towards you, okay? Towards you. Let's use, imagine that you are standing here, okay? Then this force will be coming towards you from this origin, okay? They will be coming towards you. And from, you have to point it from this origin only, okay? And if you are standing yourself here, then this force will be going away from you, from this, okay? So if you use away from you means we have upward or towards you, or we have downwards or away from you. Okay. So if this force is going away from you, then you have to use this IMD technique, IMD. Okay. Now,
Yes, sir.
can you tell me that you have to use the, now for this one, clockwise direction will be like this. Okay. So this is I So here you should place the M in this plane, or you should place this one in the here into this one. You which direction you will choose? If you choose M here, that will be MIU. Okay. And if you choose M here, then this will be IMD. IMD. Okay. So which one you have to use? IMD, because it is going away from you. Okay. So this M will be in the direction. Okay. Means towards positive Z axis. Okay. Are
Yes,
you
sir.
getting this?
Okay.
And you can choose this one. You can take this one by using your hand also. Just put the force away from you. Means put your thumb just away from you. Okay. And then try to put the middle finger just below you. Okay. Then you will find that this magnetic field line, the forefinger, will be towards your left hand. Okay. Got it?
Yes, sir.
Okay. And the question comes that technical questions. Let's move towards the technical questions. Let's let's have this one only. Okay. Let's have the same one. Okay. Now, if I'm having the same things, is my screen visible to you?
Yes, sir, it's visible.
Okay. Now the same thing. Next question. An electron is projected. Question is, an electron is projected upward. This is the direction of electron. Okay. And you need to note it one thing, that whenever this is said that east, west, north, south, okay. Whenever we are talking about east, west, north, south, then it will be always acting in the plane of paper, not upward and downward to the earth. Okay. You have to keep this one in your mind, that whenever we are talking about, when we are talking about east, west, north, south, then here it will be always in the plane of paper, and the plane of paper is this one, not the upward and downward. So it will be the north, it will be the south, and it will be the west, and this will be the east. Okay, is there any confusion to this one, north, south, east, west?
No, sir.
Now I'm saying that, now you have to answer me. Okay, question is that electron is projected upward. Electron is projected upward. Second one is, and the direction of magnetic field is from west to east. West to east. West to east. Okay. What would be the direction of force acting on it? Direction of force. Third thing is, what would be the direction of force acting on it? Tell me.
So it is emerging out of the plane force
Yes, it will be either into the plane or away from the plane now, but you have to answer me from north to south or south to north.
from north to south.
It will be from north to
South.
south. Okay. So you know that if electron is moving in this direction, then we have always take the direction of current is opposite to the direction of
Electrons.
electrons. So we will say that this is the actual I. Okay. I. And it is from west to east. So we will say that it is magnetic field direction. Okay. Got it?
Yes, sir.
So if you are standing away or on the top, if you are just standing here, okay, and you will make a circle like this, because this is a sheet of paper over you. This is a sheet of paper in the plane of, okay. So you will see that you can take MI, okay, MIU, na? So no, it is going downward now. Current is going downward into the plane, and magnetic field is this one. Then the only direction is this one. This is the z-axis, okay, that you are talking about. So that is either into the plane or, so now look, you are just looking, when we are talking about it is into the plane or towards the plane, just take it towards you or away from you. Okay. So this is M I, because this will be the circle, M, I, U, and U is towards you. So it will be this direction, and this will be north to south. So did you do it by using your fingers or by this rule that I have teach you?
So I did it by checking with fingers.
Yeah, you can do that by fingers. Fingers will be more easy for you, okay? But if you just confuse sometime, then you can do this.
Yes,
It
sir.
means this is only when you practice, when you give 1 hour, at least 1 hour, then every question, whatever this, you will do it in fingertips by using this rule. By using this rule. But you have to practice this one for 1 hour because your brain need to give the output instantly when you do this one. Then at the time you need not to turn your finger like this way. Okay, got it? Sometimes the students forgot. Okay, so this is very simple. Now again, I'm just making a new box for you. Okay. Now this is the magnetic field direction, and this is the direction of force. What would be the direction of current? Tell me. It will be positive x-axis, negative x-axis.
Sir, negative x-axis.
Negative x-axis. Yes, it will be negative axis. Very simple. Why? Because the force is going away from you. If you are looking, this is screen. So this force is away from you, or we can say that, okay, away from you, or we can say D. D represent for downward or away from you. So we have to use IMD technique here, IMD, and I should be here so that it can be clockwise. IMD. Okay, got it? If you put I here, then it will be MIU. It will be, force will be, in this case, will be here, okay? Towards you. Got it? But it is inside this one, so the current should be in this one, okay? Got it? Very simple.
Yes, yeah.
Next one. Let's have some questions regarding to this topic. And if you're stuck, then I'm going to help you, okay? Just a minute. So most of the time, see, charge of the alpha particle. Can you tell me the charge of the alpha particle? Charge of the alpha particles.
Sorry, sir. Charge of.
Alpha particles. What is the charge of alpha particles?
I don't know, sir. Charge of alpha particle.
Alpha particle is positively charged particle. Okay, so if the question comes that proton is projected in this direction, okay, then or the alpha particle is projected in this direction, so you have to answer that question accordingly. Okay,
Yes, sir.
so here we have a book here for you. Is it visible to you now?
Yes, sir. It's visible.
Okay, then tell me what should be the answer for question number 5. Question number 5. What should be the answer?
Sir, option B.
Option B. Option B. A uniform magnetic field exists. Okay. Here we have a uniform magnetic field exists in the plane of paper pointing from left to right as shown in the figure. Okay. In as shown, this is one proton and electron. So opposite the direction of proton, you can take it. Okay. So this is the magnetic field. What is the force acting will be? So you can do this one in a very simple language. Okay. And how can you solve this one? Let me help you. Okay. So how can you solve this one? You know that this is the direction of proton. Proton is actually the direction of current. Okay. And this is the magnetic field. And this is very simple. IMD.
Sir, option A. Yes.
Oh, yes, into the paper. IMD. D means downward or into the or away from you. If you are looking it from this side. So this will be into the paper. Okay. It's very simple. IMD. You have to use this trick. In simple, sometimes the question comes very simple and you can do easily MIU, IMD. Okay, this is if the direction of force is like this. The current is I. Okay, and the current is in this direction and magnetic field is this direction. So you will use simple IMIU means towards you. So sometimes this is very simple trick. Okay.
Yes, sir.
It is very simple sometimes. Use this one. No need to means use this bending your fingers like so many times. Okay, sometimes the students got confused. Okay. So next questions, if I check it here, let me just need to clear this one. I understood that. Suppose if I ask if I took a current carrying coil here because motor is not in our syllabus this time. Okay, but I'm just having this one. Okay, that this is a magnetic field. Okay, that's the question comes in examination sometimes. Just a minute. Let's suppose if we have a question here, okay, and this is the north pole and this is the south pole of the magnet, okay, and let this is a coil. This is the coil A, B, C, D, okay. This is the coil A, B, C, B. Got it? So, and these are the magnets around it, okay? Magnets around it. This is the magnet, north pole, and this is the magnet representing this south pole, okay? Can you tell me that what would be the direction of current in the coil? This is connected with uh, negative terminal here, and this is connected with positive terminal here. Okay. So can you tell me that the direction of current in coil AB, direction of force in coil AB, direction of force. What would be the direction of force, direction of force. Find the direction of force in in coil AB, comma BC, comma CD. Tell me, what would the direction of force in AB? Do you have any idea? Should I help you? Abhi,
Sir, in AB, it will be from north to south.
no, you have to tell me because these are on the plane of the screen. It can be no. Okay, whenever though no north and south direction is given to you, then you have to answer it. Okay, otherwise this will be saying that consider this whatever the drawing is being given to you, it is on the plane of paper. So it will be into the plane of paper or out of the plane of the paper or into the screen or out of the screen. So if this drawing I have made, it is just consider if no direction is given to you, just okay, then consider this one that this is in the plane of paper. Everything is in the plane of paper, whatever the drawing is given, and your answer will be either into the plane or away from the plane or out of the plane. Okay. Now tell me, is it into the plane or away from the plane?
Sir, into the plane.
Okay, let me help you. Let's check. Why? Because you know that the magnetic field direction is always taken from north to south. Okay, if it is north and this is south, the magnetic field direction is taken as, because this is the inner part. Okay, and you know that this is the outer part. The magnetic field lines always move from north to south in the okay, outside the external magnet. Inside it is moving from south to north to, from south to north. Okay, but outside from north to south. Okay, got it?
Yes, sir.
So they will be coming from here and it will be going like this. Okay. So the direction of magnetic field is this direction. Okay. This is the magnetic field. And this is whatever I'm writing, it is writing on the plane of the paper. M. And the direction of current here is, you know, the current move from positive terminal. Direction of current is taken as positive terminal to negative terminal. So here in this one, it will be like this. Okay. So it will be directly downward. Okay. Then what is the force? MIU. Okay. This is the clockwise direction. 3, 6 clockwise. So you have to choose the shortest path. This will be MIU. U means towards you. Okay. Got it?
Yes, sir.
This is M. M is this one. You took this origin here. The magnetic field is in this direction and I is in this direction. Okay. Current is coming from positive to negative terminals. So that's why it will be MIU means towards you. Here in this one, tell me, sorry, in BC, coil BC, what would be the direction of force? Direction of force.
Sir, into the plane.
No, not into the plane nor out of the plane. It will be no force will be acting on it. Okay, why? Because you know that current is moving in this direction and magnetic field is in this direction. So I've told you, if the current and the magnetic field are either in the opposite direction or if they are in the same direction, there will be no force acting on it, because here F is equals to IBL sine theta. And since you understood,
Sir, can you
uh,
explain that again?
because you know the magnetic field is from north to south always. Okay. So here the direction of magnetic field is in this plane. It will be towards x-axis, okay? In the x-axis. Got it? And the direction of current is also in the x-axis. It is because the current will be coming like this, like this, like this. So here in this BC coil, the current is in this direction. Okay. And the magnetic field is in this direction. So when here the current and the magnetic field have either 180 degree, sine 180 degree or sine 0, the both are going to have zero values. And both are going to have zero values, then what does it means? Tell me.
No force.
No force, because this will will give you zero value and this the force will be equals to zero. No force will act in. Okay, zero force. Got it? Got it? And in this
Yes, sir.
tell me, in CD coil CD.
Sir, into.